Okay, so today we're going from factored form to general form. No, we already did that. Remember, factored, and you just multiply it out. Generally, you just multiply it out to get to general, right? But the only thing we haven't done is to go from general form to vertex form. So, for instance, here's one that's factored form, and this tells me the what's? The zeros, the roots, okay? And this is a little more complicated factored form, and if you multiplied it out, you generally get general form. Would everybody please multiply that one out? Back with me, right here. In the front row. See that? That's where we are. Do that one. See, distracted. First outside and said last. So what's this one of? The museum? Okay.
Oh, I was in a museum.
Okay.
Does it automatically change or is it just your eye perception?
If you, the way you change it is you take the VR goggles off and you tilt it to the, you take your, in your right hand, you tilt it to the right. That changes the scene to something else, and then you put it back up. Okay, so anyway. All right, for those following along at home, what is he talking about? We are doing a little VR demonstration, virtual reality demonstration with talking about how math will be needed for the technology that impacts their future. Okay, this 2x squared outside negative 6x inside negative 3x lasts positive 9. Put it all together, you have 2x squared minus 9x plus 9. That's in general form, and by the way, it needs a y equals to be an equation. Some of you forgot that, and you lost your, thankfully we only did 5% off if you forgot your y equals. Not even every time, oh my gosh, some of you would have lost like 35% off your test because you forgot it 7 times, but anyway, you only lost 5% for that error. It's not like one of those where you, generally speaking, on the R3s, if you lose one of your R3 questions, that costs you 10% off your grade. But a 5% knock is much better. So, yeah, that's how it works. When there's only 4 hard questions, you have to get 3 out of 4 right. If you get any more than 3 out of 4 right, every extra question is knocking a whole grade off your test. So, all right. But the positive side is, if you only have 3 out of 4 right, you still get an A. And it's normally 75%, and that's normally not as good as an A, right? All right, so what can you plot? You can plot the x-intercepts. What are the zeros? They are the things that you can put in that make this equation 0. All right, and now I'd like to actually get to the new stuff for today, which is, everybody look at number 3. Get to problem 3. So this is saying, what could I put here so that I would get a perfect square? What a perfect square is something that would factor really nicely. Like if I had an x here and an x here, do you get that if I had put a 25 right here, that then it would factor really nicely to plus 5 and plus 5. Notice these are identical. That's what makes it a perfect square. So what are you supposed to like just try to find this number, this 25 number, like in your head? Nope, there's a trick for it. It's really easy. Take half of 10. What do you get? And then square it. 25. That's how you do it.
What about if it's a negative?
Okay, I'm going to pause for a sec. Okay, so we're back. And half and square. So what's half of negative 6? Technically, it's negative 3. But then you're going to square it, so don't worry so much about the negative, because when you square negatives, they go away. So what? 9. Now, all I'm saying is factor that. There's a reason we chose that half and square technique, because when you factor it, it's going to work out to be special. Mr. Q, what does it factor to? x and x, right? And then what? I'll give you a hint. They're identical. They're both 3's, good. And then do they have to be pluses or minuses? To make this middle term negative 6x, do you get how I have to introduce negatives somehow? And therefore, minus. Now, why, if they're identical like that, why do we call it a perfect square? Because I can put them together now and say equals x minus 3 quantities squared. And why is that good? Because that's vertex form. Get how this is general form? And that's vertex form. I could put a plus 0 there if you really want to see the vertex easier. You get how it's 3 comma 0? Because that's where the vertex lives. So it's going from general to vertex. That's exactly what's happening. Okay, let's make another one. We're kind of cheating because we're making these work. And the whole goal for today is I'll show you how to do it when there already is a number here. But you have to get this part first to be able to do it. And this is the part that I say, it sounds to me like a little German boy, Heffensquare. Heffensquare, come get your pudding. All right, so half of 4 is 2. 2 squared is 4. I don't even have to like go factor it all out. I know it's gonna. It's gonna factor to an x plus 2 and an x plus 2, and then that's x plus 2 squared. And that means it's in what kind of form? Vertex form. See how handy that is? Okay, wait a minute. What if it's a b? Half of b. So you could go half of b, and then don't forget half n squared. And I hope you wouldn't square just the b. 1/2 b squared. All right. What if it's a number like 7? Well, it's half of 7. Now, I would say it is 3.5, and that works, and this is not a wrong answer. 3.5 squared is a right answer, but I will warn you, these are way easier to do as fractions. And almost always decimals are easier. This is one time, fractions are easier. What's half of 7? 7 over 2. And then squaring it is easier, because otherwise, do you know what 3.5 squared is off the top of your head? I don't. It's 3.5 times 3.5, whatever that is. But that squared is easy. What is it? 49 over 4. Good. See how half n squared is actually easier with fractions than decimals? All right, and then if you actually had to write this, it is now two things, and it's x, and they have to be identical, right? And it's the number that's being squared, 7 over 2. Or instead, since they're exactly the same as each other, 7 over 2 squared. And now it's in vertex form. X plus 7 over 2 quantity squared. And therefore the vertex is 7 over 2, or no, sorry, negative 7 over 2, comma, there's like a plus 0 out here, so comma 0. All right, that's the half and square process, and that's the main thing you had to learn. Okay, so look at this one. Do you get that it would be really nice if this hadn't been a 20 and instead it had been a 16? You know where I got that 16 from? The half and squared. Half of 8's 4, 4 squared is 16. But you can't just say, well, I'm going to change the 20 to a 16. You can't do that. But what you can do is take the 20 and just move it over. Move it over here. Nothing wrong with leaving myself some space to work. You get how I just moved that over, and I just moved it so I could have some room. Now, if I put that half n squared number right here, instead of trying to write over my red scribble, I'm going to go half of 8 is 4, 4 squared is 16. I'm going to put a plus 16 right here. But this is an equation. I'd have to subtract 16 right here. Sorry, wait, add 16 right here to keep it fair. Because this one has a plus 16 on the right side now. And this one needs a plus 16 on the left side to balance it out. So, really, what you do then, to keep your life simpler, is yes, it. Subtract the 16. I know it seems weird. Why would you add 16 and immediately subtract 16? because we need to keep this equation balanced. You can't go around taking equations like 5 equals 2 plus 3 and then just decide to add 16 to this side. That's not going to stay balanced. But if I add 16 and also subtract 16, that's legal. Okay, so that's why we do 2 16s. But then let me explain what happens to them. This part is the perfect square, and this part is the ending to your vertex form. Would you please just factor the part I circled right here? And then everybody in here knows what negative 16 plus 20 is, and you'll have your answer in vertex form. All right, you need some accountability here. You need to be able to check and see if you're doing this right. I'm going to pair you with people, and I want you to check with them. You are going to compare with him. You two are going to pair straight across, straight across, straight across. You guys are a triangle. 1, 2, 3. Okay? You two are going to compare. You two. Oh, wait, you're working with over there. Okay, so then you're a part of a triangle. You are going to compare with Michael and Mr. Schultz, and then it's straight across, straight across, straight across, straight across. And you two are just straight across. Mikalakis, you're with the guy behind you. All right, so check and see if you got the same thing. Okay, so here's what you should have said. This part right here makes x plus 4 and x plus 4, because that's what FOILed out would make x squared plus 8x plus 16. And then that's x plus 4 quantity squared, and this together makes plus 4. And there it is, a thing of beauty. You completed the square. Now, why is this special? Because it's exactly the same as the original problem in green here. It's equal to that. Like if you graphed both of them, they would give you the same exact graph. They are the same equation. It's just written different. So this one tells me the y-intercept really easy. This one tells me the vertex really easy. That's what this is good for. And this is a really important point. So many kids, when we ask on the test, we say, find vertex. They blank out. This complete the square is the thing that gives you the vertex. So it's the vertex CTS. Any idea what I'm doing there? It's kind of like a car name. Ever heard of like a Cadillac CTS? Okay, that is a type of car. And they got like the extra letters at the end. LXI, have you seen those? Or XXL, and there's I got an LT, I got a Tahoe LT. You know, they have a lot of times extra letters in the car. Why am I doing the vertex CTS? Because if you want the vertex, you do what? Complete the square, CTS. You get that? So if you want the vertex, use the vertex CTS. Would you please say out loud, vertex CTS? All right. All right. So now you know how to find the vertex with complete the square. All right, so here's one. All you got to do to start it is move the 50 over to give you room to work. That 50 is going to be important, but it's not important right now. Put it over there. Then do complete the square on this puppy. Oh, wait, I got to see it. All right, so did you do half and square? Half of 14 is 7. 7 squared is? So if as soon as I put plus 49, I immediately have to put a minus 49. And then those two, thankfully, will cancel each other out and keep my equation equal. This part right here is your perfect square part. What did you get?
X parentheses, and I got 7, negative 7.
Is it both negatives?
One was positive.
Oh, both were supposed to be negative. There you go, because they have to be the same. Do you get if they have to be the same to be squared? All right, now there's the squared part, and then give me the final. What's that thing?
And then plus
That is a +1. There we go. What's the vertex then?
-7,
+7, +1. There we go. There's a vertex. So we wrote that green equation in a new form. We got it from general to vertex. So let me remind you, if they ask for the vertex, you're going to use the vertex CTS. Kind of like that Volvo you guys were looking at in virtual reality. I don't know what the name of that Volvo was even, but this is the vertex CTS. All right, complete the square. All right, this one's just getting bigger and bigger, so it's the same idea though. As soon as you know it's half and square, it's really not that big of a deal. What's half of 20? What's 10 squared? 100, so it's easy. Let's go to the kind that are actually on your homework. Everybody find 7.3 worksheet A. That is your homework for tonight. And question? Yes, you may. Yes. The 94 one, this one? Okay. Let me just move the 94 over first of all. And then it would have been half of 20 is 10. 10 squared is 100, so plus 100. But then you immediately minus 100. Yep. So this part right here is the perfect square part. Actually, I shouldn't have circled the y. This part right here is the perfect square part. Y equals x minus square root of 100 is 10. So x minus 10 and then another x minus 10. So I say x minus 10 squared. And you just got to put those together. So -6. All right. So your worksheet is just like that. Let's see. You may skip the prime numbers larger than 3. Skip prime numbers that are larger than 3. Larger than 3 means you can't skip 3. Okay, fine. So that's kind of like telling you to skip the even prime numbers, evil. So let's actually look at this assignment together and see if there's some that are kind of overkill. I'll pause for some. All right. So since we're doing complete the square, and let's say you did complete the square on this thing, you were finding the vertex. That makes it easy to graph, right? Once you know where the vertex is, it's like, oh, it's just a parabola that has a vertex at whatever, like, 1, 3. And if you know that, and you know there's no stretch factor, you can easily make the parabola. Because you know, oh, over 1, up 1, over 2, up 4, over 3, up 9. You should know that pattern for squareds by now. And you can just look and see, oh, there's no stretch factor, and there's no flip. So you can just make your parabola the normal way. Once you found the vertex, over 2, up 4, etc. Okay. Now, I think there's a few not too many really, but I think I can cut it down and you'll be okay. So why don't we say you can skip I think all the part B's would be reasonable. There's a lot of part B's. And all the part F's, like bullfrog. B's and F's, it's not all of them, but it's some. Take what you can get. All right, so you do the whole assignment minus the bullfrogs. And that's all I have for you for today.